All right, let's go ahead and talk about 810A congruent statements reteach, which transformations preserve congruence and orientation. Okay, so preserving congruence and orientation. Here is our object, and the table is our coordinate plane. So let's practice this and see which one does. A translation is just a slide. So if I slide this whiteout, did I change the size of the whiteout? No. Did I have to lift the whiteout off the table? No. So since I slid it and didn't change the size, that's preserving congruence. And since I did not have to pick it up, it preserved orientation. Now let's look at our rotation. If I turn my whiteout, did I change the size of the whiteout? No. Did I have to pick it up off the table? No. So it preserved both congruence and orientation. Now a reflection, when I reflected it, let's say I reflected over the y-axis, did I change the size of the whiteout? No. However, did I have to lift it up off the table? Yes. The fact that I had to lift it up for this reflection does not preserve orientation. So of the three that we have talked about so far, transformations that preserve congruence and orientation are translations. Those are your slides. And rotations, your turns. Okay? Triangle ABC was transformed to create a new triangle. Determine the transformation that occurred and answer the following questions. Okay, first things first, I'm going to get the ordered pairs for A, B, C, and D, E, and F. I think it would be easiest if we start with that. So A is at 1, 1. B, I go right 1, 2, 3, and I went up to 7. So B is at 3, 7. C, I went right 6, up 4. So C is at 6, 4. To get to D, I went left 1, down 1, so -1, -1. To get to E, I went left 3, down 7, so -3, -7. And to get to F, I went left 6, down 4, -6, -4. Okay, now I have my ordered pairs. If I think about what transformation occurred, I could either say it's a double reflection, meaning a reflection over the X and then over the Y, or I can rotate it 1, 2 turns, 180-degree rotation would create this triangle here. So our transformation is a rotation. Okay. Now I need to match up ABC matches with which letter? Well, A is at 1, 1. If I look at the points here, which one is closest to 1, 1? Well, D is at -1, -1. So D and A match up. Since A comes first, D comes first, naming the second triangle. If I look at B, the point is 3, 7. Which of these matches closely with B? Well, -3, -7. That's point E. Since B comes second, E must come second. Then if I look at C, it's at 6, 4. The closest to that is -6, -4, closest in terms of having similar numbers. So F comes next, C is last, F comes last. Triangle ABC made DEF. Now, once we have decided that, do I care about the picture anymore? No, I do not care about the graph. As soon as you have written your congruency statement and you have the letters, the graph is no longer necessary. We are just going to be matching up the letters. So angle A is congruent to what? Well, A comes first in the list of letters. D comes first. So angle A is congruent to angle D. Angle B is congruent to what? Angle B comes second. It is congruent to whatever comes second on the next side, which is E. Angle C is last. It matches up with what's last, which is F. So angle C is congruent to angle F. AC is congruent to which line segment? Okay, well, A is the first and C is the last letter, so it matches with the first and the last. So AC is congruent to DF. CB is the last and the second, so it is congruent to the last and the second, which is FE. BA is the second and the first, it's congruent to the second and the first, ED. Okay. The whole point is you need to write your congruency statement. Once that's written down, you don't need the picture anymore. Our last question. John draws a square on a coordinate plane. He then draws the image of a square 3 units to the right of the original square. Which statement is true? Okay, so here's our square, and then 3 right, here's our new square. Not a perfect drawing to scale, but let's think about it. Each side length of the image is 3 times the corresponding side length. Well, did I make these 3 times larger? No, I didn't change the size. All I did was slit it across 3 units right. The sum of the angle measures of the original figure is 180 degrees less than the sum of the angle measures of the image. Okay, well, this was a square. This is still a square. All the angles in a square is 90, so have I really changed the angles? No. So B is not right. The area of the image is larger than the area of the original figure. Did I change the side lengths? Did I change the size of the square? No. So how am I changing the area? Doesn't make any sense. The corresponding angle measures of the original figure and the image are equal. Well, an angle in a square is 90. This is still a square, so it's still 90 degrees. D is true.